So we did 2D vectors so far, and now we're going to be working with 3D vectors. So they're the same exact notation, you just add another coordinate there. So that's my v vector. When you graph this, you have to think of like the x, y as if you set it on a table. This is x, this is y, and then if you rise from the table, that would be your z. So to graph this, I would go 2 over on the x-axis. I would go 3 over on the y-axis. So it would kind of meet together at that point right there. And then you'd have to rise 4. 1, 2, 3, 4. So this would go up to like there. So it's hard to graph 3D vectors by hand. Don't worry about doing it. I just wanted to emphasize that it is possible, and if I was in person, this would be a lot easier. But there still is 3D distance. It is the magnitude of the vector. So if I said the magnitude of v, you do the same exact thing. So you're going to square root the square of 2 plus the square root of 3 plus the square of 4. You just add that extra z in there. And this is the trick that we've done before with 2 dimensions. We're just doing it now with 3. So another thing to know about 3-dimensional vectors, the angle and the dot product rules are the same. Let me write that. So when I have the cosine of an angle, that's the same as if I took u and v, dotted them, and then put them over the magnitudes of u and the magnitudes of v. So same exact rule, it's just you could also use this with 3-dimensional vectors. So also, for example, show that these are orthogonal. Well, if you remember, we don't have to go through and do the whole thing when we're just talking about perpendicular or orthogonal. If they were asking for the angle, we would have to do this and do cosine inverse theta. If we're just checking for orthogonal, all we have to do is dot product. And remember, if the dot product is 0, then they are orthogonal. If the dot product is not 0, then you have to figure out the angle. So same thing, 2 times negative 3 is negative 6, plus 7 times 1 is 7, and 1 times negative 1 is negative 1. You add that up, and yes, they are orthogonal.